you express this in the form of a plus bi, you are going to remove I at this level. Okay, our z is equals to what? 3 all over. We compute this as 2 plus 1, open the bracket, we have 3 plus 2i. Okay, to remove I at the level of the denominator, you are going to use the conjugate of this. Okay, and the conjugate of this is equal to what? That is 3 all over 3 plus 2i times the conjugate, that is 3 minus 2i. We negate the I part, the imaginary part. Okay, and that will be times what? 3 minus 2i, multiply on both sides. Therefore, our answer will be equal to, we should compute this as 3 times 3, 9 minus 3 times that is 6i. All that divided by, since it's a perfect conjugate of this, I just want to multiply this and this and this and this, because if you do overall multiplication, all the other one will subtract each other. The short trick is that you multiply directly. Since a perfect conjugate, 3 times 3, that is 9. 2 times minus 2, that is minus 4 I square. And I square, let know I for conjugate number is equal to the square root of minus 1. Therefore, I square is equal to minus 1. I cube is equal to I square times I, that will be equal to minus 1 times square root of minus 1. I to the power 4 is equal to what? I to the power 4 is I square times I square, that is 1, and so on and so forth. Okay, let's come back. That is 9 minus 6i all over 9 minus 4i square. Okay, that is what you have, and that will be equal to what? 9 minus 6i all over 9 plus 4. Okay, because I square is minus 1, and this gives a positive. Okay, therefore our z is equals to 9 minus 6i all over 30. Therefore z is equals to 9 all over 13 minus I into 6 all over 13. This is the imaginary and this is the real part. Okay, procedure. You are asked to find z to the power 6. That is argument. Argument of z to the power 6 is equals to 6 times argument of z. Okay, that is 6 times the argument of z. I knew that z is okay. Find arg z. Okay, this is derived from this graph, where you can have z here. You have the imaginary, you have the real. Therefore, argument of z is equal to tan inverse of imaginary all over real. Okay, that is how we derive it. We'll come back to our code. Okay, therefore, argument of z is equal to what? Tan inverse of imaginary, that is 6 on 13 divided by 9 on 13. That will be 6 divided by 9. And the answer, if you punch on the calculator, 6 divided by 9, tan inverse of that, you have 33.69. Okay, that is negative, sorry, I have a negative here, negative 33.69. okay, therefore 6 arg z is equals to what? 6 times the answer, that will be equals to, it comes on the calculator, and 6, that will be 201, 202.14, and so on. Okay, that is the answer. The next question, you're asked to solve for x in this inequality. Okay, bring all on one side. If we are going to have 2x plus 5 minus 4x less than 0. We have minus 2x plus 5 less than 0. Okay, from here you are asked, we can find the critical point, the CR critical point, that is 2x minus 2x plus 5 is equals to 0. Therefore, we can have our x is equals to what? Send it on that side. We're going to have 5 on 2. representing this on the number line, that is 5 on 2. If you take a value less than 5 on 2, what would be the answer? And we substitute in this equation. Take a value less than 5 on 2. You can take like 1, substitute 1 here, you are going to be having a negative. If you substitute 1 here, or if you take a value greater than like 3 or something like that, you are going to have a positive here, substituting 1, that is minus 2 plus 5. And if you take a large number, you are going to have a negative. Since we have less than, we take the negative part. Therefore, the range of value are x greater than 5 on 2. Okay. On the other side, if at this point, that is at the point of minus 2x plus 5 is less than 0, we decided to send this on this other side, okay, by dividing everywhere by negative. So we have 2x greater than 5. Okay, by sending this on this side, that will be negative 5. We divide everywhere by negative, and when you divide by negative, we change the sign of this inequality, the direction of it. Okay, that is this, and we find a critical value. X is still 5 on 2. Okay, we have to substitute back the answer. Substitute back, that is 5 on 2. We can somehow bring this on this side, so it should be easy. Greater than 0. Okay, that is how it look like. If we take a small value like 1 minus this, that is negative. If we take a value greater than this, okay, like 4, that is positive. Since you have a greater than sign, you take the positive part. So that using any method, you still have the same answer. Here also have the same answer like that. For x is greater than 5 on 2. That is the range of value. We come to the end of this video.